Hi everyone, my name is Yevhen Bodnia and I'm a student of National Technical University Kharkiv Polytechnic Institute. I, with my colleague and co-author Mariia Kozulia, would like to introduce the application system of handwritten text recognition. Nowadays, the problem of handwritten text recognition and digital image processing are attracting the attention of many researchers, occupying an important place in the most important areas of application and development of automation systems. Electronic document management has a progressive development in various areas of human activity. An important role in the field of handwritten text recognition using neural networks is played by different approaches in solving this problem, which from their advantages and corresponding disadvantages. The problem of text recognition is becoming increasingly important due to the active introduction of digital computing and the widespread use of word processors. There is a fact of number of systems existence that are able to recognize printed text with high efficiency, but the problem of handwritten text recognition remains the subject of active research in the fields of machine vision, artificial intelligence, and pattern recognition. Currently, there are a lot of software applications that require text recognition functionality. Software developers of artificial intelligence systems are faced with the task of increasing the versatility of the task performed by the software applications. More and more attention is paid to multilayer neural networks with a high degree of learning and genetic algorithms. But there is a problem of task computational complexity. The system provides graphic and structural information of the input images in the handwritten text recognition task. The list of problems with the text recognition are high variability of characters by size, inclination, component set, relationships between them, spelling errors in the text, specific features of text writing that do not allow you to confidently separate characters, text elements intersection, overlapping text parts on each other, blots, stains, media defects, and scanning artifacts, non-parallel text lines. The solution is to use the following methods: genetic algorithm, convolutional neural network, Hopfield neural network. The research aim is to compare the approaches and methods of handwritten text recognition and software development. The research object is handwritten text entered or uploaded by the user. The research subject is methods and approaches of handwritten text recognition. According to the analysis of the subject area in the work, the following tasks are set: consideration of the processes of segmentation, normalization, and feature selection, introduction to handwritten text recognition algorithms, introduction to text recognition methods and problems, consideration of existing handwritten text recognition systems, implementation of the project description and algorithmic for the implementation of handwritten text recognition system, identification of functional and non-functional capabilities, as well as the main modes of operation of the handwritten text recognition system, development, algorithmic, and software support of the handwritten text recognition system. Currently, commercial handwritten text recognition packages can only reliably recognize machine-readable forms, its questionnaires, completed forms, etc. Because using such structured documents and reducing the range of possible characters that entered of quality recognition increases sharply. These cases include the recognition of postal addresses in the automatic sorting of mail, signages on check, numbers, etc. Standard handwritten text recognition is performed according to the following scheme: pre-processing of the image, interest area selection, segmentation and normalization of the text from the area of interest, recognition of segmented text by the selected method. The task of system is to increase the speed and quality of input information recognition in order to automate this process, as well as to determine and use the most optimal method of handwritten text recognition using neural networks. A typical handwritten text recognition scheme consists of the following main stages: preprocessing of the input image, segmentation, obtaining image features, classification, and post-processing. The text recognition system receives the written text as input from receiving the image. The image should be in JPEG format. Preprocessing is a series of operations performed on an input image. This greatly improves it, making it suitable for the segmentation process. The binarization process converts a black and white image into a binary image using a global threshold determination technique. Expanding the edges in a binary image is done by expanding the image and filling in its blank area. The image processing algorithm is presented in figure below. Genetic algorithm is a heuristic search algorithm that is used to solve optimization and modeling problems by random selection, combination, and variation of the required parameters using mechanisms similar to natural selection in nature. This genetic algorithm is slower and is characterized by a stepwise improvement of the error. The block diagram of genetic algorithm is presented on the slide. The genetic algorithm effectively uses the information accumulated in the process of evolution. In the process of finding a solution, it's necessary to maintain a balance between the operation of the current obtained best solution and the expansion of the search space. Genetic algorithms show slightly lower performance than convolutional neural networks in pattern recognition problems, but have excellent calculation accuracy. Convolutional neural network is a specific architecture of artificial neural networks, which is aimed at effective pattern recognition. It's part of deep learning technologies. The idea of convolutional neural networks is to alternate convolutional layers and subsample layers. The structure of the network is a unidirectional and multi-layer. Convolutional neural networks combine three architectural ideas to provide invariance for scaling, shift rotation, and spatial distortion. Local receptor fields provide local two-dimensional connectivity of neurons. Total weights coefficients of synapses provide detection of some features anywhere in the image and reduce the total number of weights. Hierarchical organization with spatial subsamples. The structure of the convolutional neural network consists of different layer types: convolutional layers, subsampling layers, and layers of the normal neural network, the perceptron. The first two types of layers, convolutional and subsampling, alternating with each other from the input feature vector for the multi-layer perceptron. The topology of the convolutional neural network consists of 5 layers: input layer, convolutional layer, pooling or subsampling layer, fully connected layer, and output layer, which are shown on the slide. A systematic approach to image processing based on the structural decomposition of the convolutional neural network is used in the research. The sigmoid activation function belongs to the class of continuous functions, and it takes an arbitrary real number at the input and gives a real number at the output in range from 0 to 1. Large negative numbers are converted to 0 and large positive to 1. Historically, the sigmoid has been widely used because its output is well interpreted as a level of neuronal activation, of activation 0 to fully saturated activation 1. It's necessary to find the optimal values of the following parameters in order to increase the efficiency of convolutional neural networks: number of feature maps, density of connections between feature maps, window size, flow area, initial weight centralization. Hopeful neural network is a type of recurrent, fully connected artificial neural network with the symmetric matrix of connections. In the process, the dynamics of such network converges to one of the equilibrium positions. Such network can be used as auto-associative memory, as a filter as well as for optimization problems. Unlike many neural networks that work to get a response through a certain number of cycles, hopeful neural networks work to achieve equilibrium when the next state of the network is exactly equal to the previous one. The initial state is the input image, and the equilibrium gets the original image. The hopeful network uses 3 layers: the input layer, the hopeful layer, the output layer. Each layer has the same number of neurons. The hopeful layer inputs are connected to the outputs of the corresponding input layer neurons via variable connection weights. The hopeful layer outputs are connected to all neurons' inputs except itself, as well as to the corresponding elements in the output layer. The network directs data from the input layer through fixed weights connection to the hopeful layer in operation mode. The hopeful layer oscillates until a certain number of cycles is completed, and the current state of the layer is transmitted to the original layer. This state corresponds to an image already programmed into the network. Learning the whole network requires that the learning image is presented in the input and output layers at the same time. The output layer, recursive nature, provides a means of the corresponding order that joins weights. The IDF0-diagram of the handwritten text recognition process is shown in the figure below. The control input is the handwritten text. The control outputs are the recognized handwritten text and saved text to the dictionary. The mechanism includes the following roles: the text recognition system, the graphic editor, the information storage. The control elements are standards, methods, and algorithms. The decomposed diagram shows the 7 functional blocks of this process: the text-image vectorization, the image and graphic image recognition, the calligraphy and graphic sign evaluations, the recognized text formation, and the information storing. The use case diagram shows the relationship between actors and precedents in the system. This diagram clearly shows the distribution of function performed by the system for the actor user. The user has full access to the functionality of the text recognition module and additional configuration options for neural network parameters. The sequence diagram shows vertical lines as different processes or objects that exist at the same time. Sent messages are displayed as horizontal lines in the order of sending. The sequence diagram indicates the order of messages and system objects between which messages are passed or methods are called. The deployment diagram shows the computer nodes during the program, component operations, and objects running on those nodes. Also, it shows the component's working instance and the relationship between their component types. The deployment diagram shows the topology of the system and the distribution of system components on its nodes, as well connections, routes of information transfer between hardware nodes. The web application using extends to all countries. The application is designed for handwritten text recognition in Ukrainian. The web application applies to all users and works in all popular web browsers. The application uses a minimalistic user-friendly interface that is intuitive for all users. Functions that are implemented in the presenter software application: create, view, modify character mapping data for neural network training, providing access to the web application via the internet, neural network training and configuration, recognition of handwritten Ukrainian text. The web application should allow the user to map the entered character to the character from the database in order to learn neural network in detail. The web application is based on HTML5, SCSS, Vue.js framework, TypeScript language, Node.js platform, and Tesseract.js library. The user interface of the application consists of the following 3 pages: recognition, the home page with the ability to recognize handwritten text; training, the page with the ability to learn neural networks; settings, the page with the ability to configure neural network. The following tests were performed to test the problem solutions. Entering a compressed handwritten word. You can see the result on the slide. Entering a handwritten word at an angle. Entering a handwritten word in the waveform. The neural network was trained to recognize each letter on the Ukrainian alphabet with a different type of handwriting. As a result of testing the problem solutions, we can conclude that the application had the ability to recognize handwritten text in its various positions. Composing the indicators of quality and speed of recognition, it can be argued that the most optimal recognition of the Ukrainian handwritten text is carried out using the convolutional neural networks. Handwritten text recognition quality can be improved by learning neural network in more detail. As a numerical experiment, handwritten text was entered to verify the cost of time resources by the recognition application. As a result, existing solutions were compared with the developed applications. The results are summarized in the table below. Finally, let me just sum up today's main topics. The application is a handwritten text recognition system that includes feature selection and segmentation subsystems. Improvements and enhancements to the functionality of the application are planned in its next versions. Text representation allows further processing of information obtained by scanning or photographing. The relevance of text recognition has increased with the advent of e-book readers, making the reading process easier. Optical recognition has greatly facilitated the document flow process. Based on the analysis of the subject area and the considered methods for solving the problem of handwritten text recognition, it was found that the speed and quality of this subsystem meets modern requirements. Effective solutions to the problem are demonstrated using genetic algorithms, convolutional neural networks, and hopeful neural networks. The presence of many existing libraries based on the JavaScript programming language emphasizes the development of handwritten text recognition systems in software engineering, which accelerates the software development process to automate the task in this work. The software solution used a stack of technologies: HTML5, SCSS, Node.js, Express.js, MongoDB, Mongoose, Vue.js, which is an integral part of web application development. High-speed software was created based on neural networks and genetic algorithms, which in turn has a high priority in modern research in this field of science. The application will be expanded, namely the recognition of handwritten text entered by the user in English and Russian. Thank you for your attention.